Good evening, everybody, and welcome to another episode of vBrownBag. This evening, we are going to continue our Python for DevOps series, talking with Python developers and learning how to level up our skills. And we have a great one tonight. Tonight, we're going to be talking with Paul Everitt. He is going to be talking about visual debugging with games, and he is a developer advocate over at Pycharm. So he knows what he's talking about. He's got the skills. Paul, are you there?
I sure am.
Hey, Paul, how are you doing tonight?
Great. Thanks for having me. Thanks, vBrownBag, for having me on this session.
We're very excited to have you on board. Before we get started, I would like to do a couple of quick housekeeping notes. If you are in the audience, if you're in the Peanut Gallery, feel free to give us a shout out, ask questions as we proceed. I will be paying attention to both the live Q&A in the webinar pop-up, and I will be paying attention to the tweetosphere. So if you @vBrownBag or #vBrownBag, I will be paying attention. As always, we have our other branches, APAC, EMEA, LATAM. I will not be paying attention to the LATAM or EMEA Twitter hashtags, so don't do that there. Without further ado, again, we have our guest this evening. It's Paul Everitt. He is @Paul W. Everitt on Twitter. My name's Chris. I'll be hosting. So, Mr. Paul, let me give you the power.
All right, thanks.
You have the power.
Let's see if I can remember the name of the screen that I'm supposed to aim for. All right. Do you see my Pycharm?
Yes, sir, I do.
Oh, phew. You know, whenever there's a 50-50 choice in life, I get in the wrong line.
I've heard you're supposed to always take left.
Great. As Chris mentioned, let's have some questions. What's the record for number of questions that you've had, Chris? Let's try and break that.
Record for number of questions. You know what? I've never even counted. I have a record for the length of a presentation, but I do not have a record for the number of questions.
All right, you can see my screen. Chris, how's the font size? Is that readable?
It is very legible. Perfect.
All right, cool. For anybody who wants to follow along, over on the side, I have a markdown document that says what. The dot there. What's that?
Boop.
All right.
There we go.
There. Too OCD. There's the URL if you want to follow along on the code and this markdown document that has essentially the slides. One could view these slides as helpful to you so that you know where you are, but pro tip, they're actually reminding me what the bleep I'm supposed to be saying. So this is the outline of things that we might talk about. The context is debugging. Debugging is an essential skill for programmers, but what happens is most people wind up doing debugging with print statements instead of spending a little bit of time to learning the debugger. In Python, the debugger is called PDB. It is a command line interface. It's a little bit arcane, and so you still find people doing print. The premise of this talk, this webinar, is what if you could do visual debugging? Would more people do debugging if they had a pretty face that made it easy to figure everything out? So we're going to talk about the use of the debugger. We're going to go over breakpoints and a number of other features, and we may tailor that to the available time and what you and the audience want to see. Chris has advised me wide and shallow. Is that correct?
It's definitely going to be. Oh, well, so let's hold on. We've already got a question. No. Disregard. We have some chuckles in the audience as we proceed.
Is it about my redneck accent? I mean, you can be honest about it.
Absolutely not. No. I have a gentleman named Graham who is a prolific attendee, and he asks lots of questions. So he pops up and says, "Questions, you say?"
Good.
I have several.
He's going to set the record by himself.
He has.
Okay. We're going to talk about some concepts that, according to Chris, you went over in a previous session on PDB, things like breakpoints, but then some of the things, and stepping through breakpoints and the kind of flow of a debugger, but then some of the things that visual debugging, in particular, in this case, the free and open source version of Pycharm Community Edition, will bring through it. So as a kind of a setup for this, I'm sitting in Pycharm right now, and I've got some Python code on the left. I've got this markdown document on the right. And this doesn't look like the out-of-the-box Pycharm. I'm using the Darkula theme, which is built into Pycharm. So it has kind of the dark look that all the hipster cool kids use. I've got the fonts a little bit bigger. But most importantly, I've turned off a lot of crap. We don't have the project tool because we don't really need to see files. I'm going to work in one file. I turned off tabs because we're only going to work in one file. Don't need tabs up there. More importantly, I'm a tabless guy. I've turned off tabs and I use other ways to move around in code than files and tabs. I also turned on, installed a plugin, and I turned on something called Presentation Assistant, which lets me show you at the bottom the keystrokes that I use. And I'm on Mac OS, but it also shows, for example, what it would be on Windows or Linux. So that helps you follow around a little bit.
Nice.
That gets us into the setup. Let's go straight into debugging. Chris, any points to add before I get started?
No, sir.
All right. This is a game. Everything's more fun with games, especially debugging. And so we're going to take a look at some features in this game. It's just a simple Dora the Explorer 2D kind of game using a Python library called Arcade. Arcade's a semi-popular 2D system. So if I run this code, I get on the wrong screen. I hope it's not like that the whole time. I get a little game where I can go around, pick up some coins, and watch my score go up. Pretty fun, and not a whole lot of code. That's kind of the best part of it. It's a good teaching environment. And I just ran the code, but I want to find find out something, a very basic question. All these game systems, they have a different concept of where 0 is. And Arcade puts it in the place that carbon-based oxygen-breathing humans would put it, the bottom left, but a lot of others put it in like the top left. Let's go figure that problem out. So if I was doing this without knowing much about debugging, I might do something like, okay, well, this is the place where the mouse moves. And so I'm going to put a print statement in here. I know a little bit about this code. I know that Arcade passes in the X and Y position of the mouse. And so I'm just going to print X and Y. Or I'll just print, I'll print X and Y. And then I'll run my code again. Wrong screen. This is going to be fun. Okay, there we are. And I'm going to move around until it's like, okay, that's not it. Okay, we're getting closer. One of them is right. So it is the bottom left. That's where my 0, 0 position is. But in order to do that, I had to go change my code and put a print statement in. That's kind of a bad thing. You might accidentally ship it with that in there, and it doesn't really give you too much interactivity to poke around and things like that. And so that's a really good place for debugging. So we did debugging with print statements. Instead, we could do the old Python import pdb.setTrace, rerun our code, and it would stop whenever the mouse moved. So I'll run it. Wrong screen, back over here. All right, and I'm going to move my mouse so that I don't move it a whole bunch. And as soon as we come in, I get into the PDB prompt. And my game stops execution because we're in the debugger. We're at something called a breakpoint. I set a breakpoint right there. I could be using the new Python 3.7, 3.8, whatever, way to set breakpoints, but this is the most famous way. And at this point, I could do some various things to list some things and print some things like the value of X and stuff like that. And this kind of shows the pitch for visual debugging. It's already intimidating. I've got to learn this other language, which is the PDB language. And it's not the same as the Python language. It's just a language for debugging. And not only that, but I actually edited my source code to put something in. And boy, you put that into production, then every time everybody's mouse moves, the game's going to lock up. So that's not a good thing. we'll stop this game. Yep. My game's up. Nope. Force quit. And take out that, and let's do something that's visual debugging using this IDE integrated development environment called Pycharm. Everything I'm showing is available in the free edition, and use visual debugging as a way to recreate what we just did. By that, I mean this. I click in the gutter beside the line I want to stop at, and it sets something called a breakpoint on that line. And now, instead of running my code under the runner, so to speak, I'm going to run it under the debugger. I'm going to briefly turn on my toolbars so that you can see the thing that you would normally use is this one right here. So I click on this to run the game under the debugger. And when I do, these breakpoints kick in, and my game, when I put it back on the screen, I moved my cursor and it stopped on that line the same way that import pdb.setTrace did. But it didn't alter my source code to do it, and I get a lot friendlier of a UI for exploring all the values that are available at that place in the execution that I've stopped at. I have an X, I have a Y, the X and Y position of my cursor, my mouse at the mouse cursor. And then the change in X and change in Y, which is other parts of the contract for that method. And then I have access to self, and with access to self, I have access to the universe. And we'll talk about some more things in this variable viewer. And in fact, you can edit things in the variables and change their state, not just look at them. So visual debugging let me use a breakpoint set outside of the code to do the same kind of exploration that I was doing with print statements and with the import PDB statement. So I'll stop there and see if we've got anything, Chris.
One moment. Hold, please. Yes, Pycharm only or...
That's pretty clear.
For en español, marque número dos. Pycharm only or VS Code 2 for debugging?
VS Code also has some visual debugging. And there, I mean, I present this as a concept rather than a product.
Understood.
Because you can get in Visual Studio, VS Code, Komodo, lots of tools have this concept of visual debugging, but we've been doing it since Moses was a kid.
Really? Python's only, wait a minute, never mind.
All right, anything else or go on?
No, please continue. That was it.
Okay, sure. Let's look at another problem we'd like to kind of solve using debugging, kind of exploring before committing to some code. And I've got this line here, which is an old-fashioned Python string formatting approach, like going back to the original version of Python for doing printf substitution. And I'd like to kind of explore Python's new f-string syntax. In other words, I'd like to the result to be this thing on the next line. But I'd like to do it in the context of my code and the state of my program at that line. So what I'm going to do is, rather than putting 1,000 print statements and rerunning my program until I randomly get it right, I'm going to put a breakpoint, run this under the debugger, and it will stop at that line. And from here, I can start playing around. What's the first way to play around? Bring up our evaluate expression tool. And this is like a Python REPL right here that happens to have everything in scope and can do autocomplete. So I could do, 1 + 1 and evaluate that expression. But I could also say self.score. And you saw that I have autocomplete because the IDE knows the scope that I'm at, what variables are available. There's something called self, there's something called score. And I can gradually work on this and say things like, okay, what is it? No, it's not that. It's this thing with an F in front. And then when I want to do score, and then it's got this curly bracket thing, and inside now I'm out of string and into Python. And oh, look, I can autocomplete. Oh, and I can autocomplete again. But then there's something after that. It's like 0, 2 for the formatting and a D for a decimal. I wonder if I've got it right. Hey, look, I've got it right. It's currently 0.
Nice.
And I can evaluate. I can remember things I evaluated previously. I can rerun in the debugger. And let me get my game back over here. And it stopped again. And I can continue and have it just keep stopping, and the score continues to be 0. But if I take the breakpoint out, go back to my game, I think my game is frozen because I had a breakpoint in there. So now the game is resumed, and as I move around and my score goes up, I put the breakpoint back in there. I don't have to restart my program whenever I move breakpoints around. Another advantage over print statements or PDB statements.
Nice.
Now it stopped again, and look, self.score is now 11, which is what our game said it was. So I was able to poke around and gradually build up the F string until I got to the point that I wanted. And I was using our GUI called Evaluate Expression. If I wanted to and use something a little more familiar, I could go to console and then click on the Python prompt. And now I'm in the actual Python REPL. And in fact, if I went over to my interpreter, if I went through the work to install the IPython command line tool, then I would be using IPython at the REPL instead of our command line handler. So different ways to do this. I can poke around in the GUI. I can bring up something that lets me type expressions, or I can go to a console. Oh, and I failed to mention, just inline in here, we have, let's say I step, I'll do this instead. I'll run to that one. We put these pseudo comment things to show you the values of everything that is computed in that scope. So you don't have to come down here all the time and think, okay, I'm looking for output. Where is it down here? Instead, it's at the end of the line. And so that's a nice way to poke around as well and to see the values as you move through the code. All right, that's it for poking around. I'll take some questions if you've got anything.
The boards are clear, sir. Oh, wait.
Good.
Am I lying? Oh, wait, no, I'm not. I am lying. And when you drop to the command line, are you still within scope?
Yes, I am. In fact, hey, good question. Let me stop here. I could actually cheat.
Yeah, I was going to ask. Can you swap it? I was going to. So that actually affects the runtime.
That affects the runtime. Let me go see if I can get back to my game.
Nice.
Look at that score.
He's so good at that game.
Yep. It's almost like you and I planned that.
Full disclosure, we did not. We're just that good.
So to take away some things from that, don't use print statements, don't type in import PDB, use a visual debugger, and you don't have to restart your program as you change your mind about where you want to poke. In a running program, you can just move your breakpoints around. All right, onward. I'm looking at this code about update, and it's kind of the important part of this game library. It calls this function 60 frames per second, 60 times a second, but it will pass you in this value it computes called delta time. So you think, what is that? Well, I could go look at yeah, I do. Oh, it's in a lot of places. I could go look at arcade its window and figure out what it is. I could go read some documentation, or I could, in the interest of poking around, poke around. I could set a breakpoint here and then observe the value and then click continue in my debugger to keep running and watching that value change. So let's do that. I'll run my game. And it stops immediately because I've got to do the first update. And it's going to do this frequently. And you see the first time it stopped at the 0.07 second mark, which is pretty fast, somewhere in the ballpark of 60 frames per second. But watch what happens when I say continue execution, resume program, and tell my game to run back to the point at which this line is executed and then stop. And it's going to be a lot higher because I talked for 34.5 seconds.
Mm-hmm.
But if I talk less time, 6.7 seconds or 2.16 seconds or 1.3, then I can kind of get a feeling of what delta time is about by running my program and inspecting values as they change over time.
Mm-hmm.
All right, so I'll clear the breakpoint and click resume so that my program continues running. We already talked about setting a breakpoint. Let's simulate another kind of problem.
One more quick question about breakpoints. The question is, I'm guessing that it's IDE dependent, but if you set say 20 breakpoints in this session, can you save off the breakpoints and have them there tomorrow when you come back to debug?
The first point is correct. I have no idea if other tools do it or not. I suspect they do. In our tool, if I click here and click here, close Pycharm, and shut down my computer and go on a vacation, come back, reopen this project, it will remember where my breakpoints are.
Nice.
Does that answer the question?
Yes, that did.
All right, cool. Okay, let's say that I'm working on my code and it's broken for reasons that I can just stare, and despite the fact there's a little squiggly, I cannot, for the life of me, figure out why when I run my game, it actually does that. It's like, okay, yeah, Python's telling me exactly what the problem is.
Yay, Python.
But it's been 10 cups of coffee, long day, and I'm like, character, that's exactly the name of the file. So what I could do is I could set a breakpoint right there and go stepping around into code and taking a look and seeing what the problem is. So this time I'm going to run it, and it's going to stop immediately before the game even gets loaded because this is the constructor for my game class. And I could take a look around. This is from later in the episode. And see some things and poke around and see what the problem is. And I'll skip to the chase a little bit on the next section. I could step into this line of code. Instead of going down to this line, I could step into the execution of that line and then keep stepping over some things until I get to the problem where I find out, oh yeah, I've got a problem with that file. And then gradually discover that, oh, this file name is the one causing the problem. I could also do something, though, where I could set up Pycharm to do what it's doing right now, which is automatically stop on a certain kind of exception. So what I'll do is I'll stop this. So the game's not running. I'm going to go back to my game, and there are no breakpoints. And if I run my code, it's going to fail. If I run my code under the debugger, it's going to stop on the line that has the problem. This line is actually in the Python imaging library, aka Pillow, in the image module, and it's trying to open a file name that doesn't exist. I didn't set a breakpoint. Why did Pycharm do me a solid and stop on that line? I'm going to go to Manage Breakpoints, which is, visual debugging, puts a UI on all of this. And by default, Pycharm has a way to stop on any exception in Python. Now, that can be a little bit annoying because there's a lot of exceptions.
Right.
But you can configure it a little further and say, only stop when it doesn't get handled by anything. And then this one's great because you can say, only on exceptions in my code. If it's a code somewhere over in Python or one of the dependencies, don't worry about it. Don't stop and annoy me constantly. But if it's an exception in my code, don't make me go set a breakpoint and recreate it. Just stop and give me a chance to fix it. All right, so that's breakpoints. One last thing to talk about is this concept of frames. So I'm stopped on this breakpoint, and this is in the file in pill called image.py. I'm like, how did I get here? I've lost the plot. You helped me by stopping me 27 turns off the interstate. But I was sleeping the whole time. I don't know how we got here. How did we get here? This thing over here called frames lets me use something called Python stack frames to look at all the calls to get here. And eventually I get to my line in my code, which caused the problem. I'll just give a quick talk about and not actually show it because we're already getting a little low on time. One other thing I can do for breakpoints that's really cool, if I wanted to set a breakpoint, I'll go ahead and do it. Let's say I'm having a problem with the formatting of 2 character numbers instead of 1 character, and I don't want to have to do continue 9 times until I get to a score of 10. I can go configure a breakpoint, and I can say only stop if self.score, hey, look, autocomplete, is greater than 9. I can set a condition for when I want to stop on a breakpoint. As you get good at breakpoints, this is the very first intermediate skill you will acquire, which is don't make me click 1,000 times. Only stop when I'm actually going to have the problem. Okay, before I go on to the next section, any points?
So you enabled that function by double clicking on the breakpoint in the gutter?
I did a right click. I did a right click on a breakpoint. I set a breakpoint and then I right clicked on it.
Gotcha. Cool.
All right. I guess I need to probably speed up. Chris, you want to give me some tuning on the breadth versus depth?
Oh, I think you're doing fantastic.
Right, cool.
Questions are being asked, and you're knocking them out of the park, and we've still got plenty of time left.
All right, cool.
Good pace.
Okay, stepping. The problem we want to investigate and learn about stepping is 50 coins. We got 50 coins at random positions. Are we sure about that? Is random actually doing the right thing in my for loop? I'm going to go down to where I talk about stepping, and I've got this for loop that goes and does 50 times. It makes a coin, and then randomly finds an X and randomly finds a Y. So I'm going to put a breakpoint in here. I'm going to run under the debugger, and it's going to stop when because I didn't fix my character.
I was going to say character.
Thank you, Chris. Thanks, Dad. Hey, now when I run it,
clean up your room.
Well, that never happened. It's going to stop when I is 0, the first time into the loop, when it's making the first coin. And at this point, I've got coin.center under X. Let's see what that value is. And I'll speed type. And it's 494. We haven't assigned Y yet. If I step over, meaning go to the next line, then I see center under Y has been set. And I can keep stepping. Step, step, oh, back to the top, step, step, step. This next one is going to be an X of 125 and a Y of 160. Step, 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 step. And so I can step and I can step, I can step. And that works pretty well. I can also avoid all that stepping by saying resume program, and it will continue running until it hits the next breakpoint, which in my case is exactly what I want. I equals 4, I equals 5, etc. And so that all worked pretty well. I could also, though, I'll stop this. I could set the breakpoint on the outside of the loop. This time when I run it, I will stop before I get into the loop. And as I step through my code, step over, it's still going to go into the loop, et cetera, et cetera. This time when I do resume execution, though, it's never going to hit this breakpoint again because it's outside of the loop. And my game is running. So that all works pretty well. But I might want to step into things. Step over goes up and down. Step into goes kind of left and right or in and out. In this case, I want to go see how a sprite is actually made. How does coinUnder1.png turn into pixels on the screen? So this time I'm going to run under the debugger again. It's going to stomp on that line. And instead of going to this next line with step over, I'm going to say step into. That's what we were looking at a little bit before. And I'm now in the sprite classes Dunder and Net constructor, and I can do my step over thing again. Step over, step over, step over, step over. Oh, file name. That's the first argument. Load texture. What's that? Okay, I'll step into that. I'll go to the right instead of down. And so load texture, we see that we're in the load texture function, is something in arcade draw commands. And it does a whole bunch of stuff. Now I'm 27 hops off the interstate. I'd like to get back out. So if step into got me to the right, what gets me back out? Step out. So I step out to the function that called me, and if I click it again, I'm going to go back to my code. And I can step over, step over, step over. That all works pretty well. Sometimes, though, you wind up wanting to step into code, but only your code. You don't want to go off into library land, which has things calling things. And you know they work because somebody would complain about the Python release. It's your code that you want to step into. And that's the miracle of this button. That's the one you usually want to use. Only step into my code. It's not going to step into, it's not going to go to the right in random. It's only going to go to the right in my code. And then one last point, let's say I'm stepping over. I'm like, oh no, I just want to jump to here. And maybe here is like 50 lines down. This one, run to cursor. Oops, sorry.
Nice.
Run to cursor will do the moral equivalent of putting a breakpoint on that line without the overhead and hassle of setting a breakpoint. All right, I'll skip this one in the interest of time because we've gone through stepping enough. Anything else before I go on?
No, folks are saying thank you. This is really good stuff.
As a note, we're doing all this, and yeah, I was complaining about my game being on the other screen where we can't see it, but I'm able to accomplish a lot without having to look at my actual output. I'm staying in the code. I'll have to context switch to another window. Next step up on the Zen level, watch expressions, a way to be far more productive when you are working on your code. So for example, is the number of coins actually decreasing when I'm doing collisions? So as a hint, collisions happen here in the, gee, that's a good name, check for collisions. I get a list of things that might have gotten hit in the last 1/60th of a second and put it in a list, and then I iterate over them and I kill them dead, and then I increment my score. Is that actually working? Well, let's go find out. So I'm going to go run this under the debugger, and I see that the first time this runs, I'll run again, my game is up over here, and as I move around, nothing happens until, all right, I hit something. I'm in the hit list. How big was my hit list? oh crap, I'm going to have to go look at this thing and maybe expand it and see how many items are in it or do it. Oh, can't you just let me put an expression and I can watch that expression down here? Something like len of self. Oh no, actually len of hit list. Oh, look, it's 1. Okay, so I hit one thing this time. Let me go back to my, oh no, I hit more than one thing. All right, cool. Multiple events fired in that little bit of time. Okay, I'll see if I can get 4. Okay, so my hit list, well, 3. I got 3. So this is a case of using watch expressions to avoid expanding and going down to the and doing it's a nice way to summarize and focus on not just the value, but the expression of the value that you're interested in. So watch expressions are really useful. All right, probably no questions, so I will continue. We talked about stack frames that help you see the layers of execution in Python and how do we get to a certain place. I'm going to go on to a topic that is near and dear to my heart, testing. Test writing might be a little bit more advanced than what the vBrownBag people are doing, but it's a way of working that I find really productive. I do test writing not to eat my vegetables to generate quality, but rather I'm lazy and I want to code fast. And this is a fast way to code. So the idea of a test is I have some code and I write some tests for that code. And the tests are also code, but they happen to be code for the purpose of other code. And I go into test-driven development, TDD. I go into TDD mode in my brain by having my code that I'm testing on the left. I have my tests on the right, and then I have the visual testing Pycharm cool thing at the bottom. The way that looks is I split vertically, and I will turn this off. Yep. And over here, I will reopen my test code. So this is the thing that's writing my test. And then when I run my test, it will appear at the bottom. And the scenario is I'm going to add a way to stop a game and finish and then restart a game. And when I add this feature, rather than just jumping straight into the code, making sure right until it works, I'm going to write a test for it, and that test will fail because I haven't implemented the feature. And here's my first test. I want to see if the game by default is stopped. So I'm going to run this test, and it's going to fail. It's going to fail because I don't have an attribute on my class called isStopped. Like, oh yeah, duh. Got to go in here and say self.is_stopped equals true. Now when I rerun it, my test passed. Yay! And in fact, I can go one step further and turn on auto run mode so that as I run and do my coding and wait for a configurable amount of time, without even having to save, my test will run. Now, as I do that, I may have been like, how did that even be a problem in the first place? I wrote my test and like, why is this false? Well, let's throw a little bit of debugging, a little bit of visual debugging at it, and use the skill of debugging combined with the skill of testing. The two go together very well. Test writing is an exploratory process, and debugging is a way to speed up exploration. So I'm going to put a breakpoint in my test. I could put it in my code, but I'm going to put it in my test. I'm going to run this test. I'm going to run it under the debugger. And when I do, execution will stop on that line. And I can do my whole, what the heck? Why isn't my game stopped? Actually, I need to recreate the moment by getting rid of that. All right, rewind. I'm going to run it under the debugger. Oh, set my breakpoint. I'm going to run this under the debugger. And execution is going to stop on that line. I'm going to be like, What's wrong? Why isn't the game stopped? Is it false? What's its value? I can come down here and I can poke around and I can look for is under stopped. And it's going to say, nope, you don't have it. And I'm going to say, no, you're wrong. Game.is under stopped. Duh. Attribute error. Oh, attribute error. That must be because I never added it to my class. So I will continue execution, let the test fail, come over and say, oh, yeah, is under stopped equals true. And this time when I run it under the debugger, and I stop on that line, and I expand that, and I say is under stopped, it's right there. Or I could put a watch value, since that was so far down, I could say self.is under stopped, and it would, what do you mean self is, oh, game, duh. Game.is under stopped, and it would say true. Or I could go into here and say game.is under stopped, and it would say true. And all these poking around in interactive exploration during the writing of tests help reveal problems either in my test or in the code that I'm writing the test for. So I will stop on the test writing part at that point, see if there are any questions.
A quick question about stacked frames. When you're showing the stack frames, can it only show your code, or does it have to show all the library calls, etc., that have been called, or can you toggle it?
I don't know about toggling it. That's a good question. I think it's going to show all the stack. There's some speed typing in there, but I think it will show the entire stack.
Gotcha.
Which can be very frustrating in frameworks like Django and stuff, where there's a lot of framework in between you and what calls you.
But then that's when you can use the calls to actually highlight your attributes.
Yeah, right.
To move you to it. Cool. Yep. Okay, thank you.
And I will say it's cumbersome clicking around those 27 hops off the interstate, but a lot of times one of those hops changed the value, and that's where your problem was caused.
Gotcha.
Okay, on to attach to process. And then maybe in the interest of time, I'll skip down to the Django and Flask thing and wrap it up.
Okay, sounds good.
I'll skip the extract type information. I'm running my code inside Pycharm and letting Pycharm initiate the running of the code. Sometimes you don't have that benefit. There's something run, and what I'm about to talk about on attach to process only works on a local machine because it uses OS level APIs. Sometimes there's something running already and you need to go connect to it. It's embedded into something, or it has a launch thing that you can't hook up to Pycharm. So for example, I'm going to go to the terminal in Pycharm. I'm going to run Python. Yeah, okay. I'm going to run it in theory outside of Pycharm. And the game's going to come up over here. And I'm going to be playing around, but I'm like, this whole score thing, is it working right? Oh, crap. What am I going to do? I can't run it under Pycharm. But what I can do is set my breakpoint on that place where I'm calculating the score instead of breakpoint. And then I'm going to do some magical, don't ask Paul how this works, attached to process. It's going to give me a listing of things for Python on the local machine. Some of you may notice Dropbox is implemented in Python. So you actually, if you use Dropbox, you, for the time being, have Python running on your desktop. Anyway, blah, blah, blah. So I see, oh, game, that's my thing. I'm going to go attach to it. And tell Pycharm, this thing's already running. Really? I said yes to you this morning. All right. And it's going to use some special operating system hook things to connect to the Python that's already running and stop on that breakpoint. So for example, I will now change that and resume. and my game's running. Let's say that what I wanted to do was in the middle of the hit list, stop there. Remember, my game is still running over here.
Mm-hmm.
So I'm moving around, nothing's triggering the breakpoint until poop. Attached to process found a running Python program, and I moved my breakpoint while it was still running to a different place in my code, and it stopped at that line. I find stuff like that to be just magical.
That's really cool. So I saw that you had that pop-up that said, so does Pycharm ask, but effectively you interrupted a running program with hooks from Pycharm into it. How does that require special elevated privileges to get into that? I saw the developer pop-up thing. Was that because of what you were trying to do?
Yeah, I don't know if it's a one-time thing or what, but it was, Mac OS Sandbox probably said, hey, a different program is trying to use deep voodoo magic instead of an official API to talk to you.
I'm going to try that on Windows now.
I know it works on Windows. I don't know if it pops that thing up, but most of our customers are Windows, so I'm pretty sure it works on.
That's super cool.
Yep. All right. Before I get into the last point, anything come in?
So, as soon as you said deep voodoo magic, that I'm not going to explain how it works, somebody said, so how does that work? But they were being sarcastic and facetious and a bit of a smart verse.
Yeah, there are various operating system ways to go find a process that's running on your computer and use these various OS level IPC things to go and grab it. And what we're doing is we know it's a Python interpreter, and we are at runtime going and injecting a breakpoint into it. And I guess we're doing something in the code that we're injecting into it sends back over IPC to us the debugger information that lets us remote control it. Jesus, I don't believe anything I just said. All right. One last thing. Django is a very popular web framework for Python, Flask as well. For both of those, you develop in a way where you have some Python code in a view, and you have some template code. Oh, we allow browsing of databases, but that wasn't the point. We allow some template code in an HTML-like language that has some Python little looking things in it. And a lot of the time, this is a bug magnet for your project. And it's a place where all of your tools can't help you because it's not Python anymore. Can't exactly, trying to put an import PDB in here, all bets are off, except we support putting a breakpoint in your templates, not your Python code, in your templates, Django templates and Jinja 2 templates. So this last thing, if I run it under the debugger, Django. If I run the Django server but run it under the debugger, it's going to come up. It's going to be happy. It's going to ask me, hey, you want to click on this? Sure, I want to click on that. And when I do, it's this view that I went to. It's going to stop on that line. And it's going to show me everything that's in scope inside this quote unquote for loop in a template language. Just as if I was stopped in Python. And I get the whole frame thing, and I get the whole watches thing, and evaluate expression thing, and I can step over. And I can watch my counter. I'll do a watch so it's easier to see. Watch my counter go up. And then I can change values. I can poke around to evaluate expression. And when I'm done, I can resume, go back to my browser, and there's the output of my template. I can even navigate to different parts of my code. If this is findable in the view, I can do Command B to navigate to it. I don't know if I set it up right. Yeah, I didn't set it up right. All right, the best 2 words in any presentation. In conclusion, this is a talk about debugging. This is a talk about visual debugging, a way to get into to debugging if it's something you've been postponing, you know you need to do it, but don't. This is a way to get into it. And this is a way, frankly, to be more productive by having mature visual tools guide you through all the activities in debugging.
Absolutely fantastic. Thank you very much for that.
My pleasure.
For all of those listening in the future, after this has been recorded, this is an excellent follow-up to the previous episode that we had with Chrissy Wainwright, where she did PDB. In that we learned the value of debugging, and today we learned how to become extraordinarily fast with it using visual debugging in Pycharm. So if you are in the future right now and you haven't listened to the Chrissy Wainwright one, I have a hard time saying that name. I don't know why. I highly encourage you to now go and watch that one as well. That was fantastic. Let me check a couple of things real fast to make sure that all the questions have been answered. A couple of comments. Excellent session. Great follow on. Can he come back and do more and deeper?
Testing, baby, testing.
Yeah, absolutely. We can certainly chat about that offline. That would be a great follow up. We did the shallow and broad. Now we could do the single instance and deep.
All right.
Cool. Excellent. Let me do one last quick scour of the peanut gallery in the comment section and the Twitter sphere. Folks saying thank you very much. Excellent information. Good job. Huzzah, Paul. Cool. All right. Yes, thank you very much for doing this. This was fantastic. I am now going to immediately go reinstall Pycharm on my primary driver and play with the PID hooks. That looks really fun.
Go write some games.
Yeah, exactly. Well, I'm not that good yet, but I'm getting there. Awesome, Paul. Thanks very much once again, and have a great night.
All right, thanks, Chris.
All right, bye everybody.
Bye.